Hello everybody. Today in Knowledge Charity, Module 2, we are going to have a look at basic properties of electric charge followed by applications of Coulomb's law of electrostatics. Maybe we will solve a few problems. So what we are going to see today is the basic properties of electric charge. The first three properties we will have a glance, and we will then proceed with the applications of Coulomb's law. Fine. Yesterday we have seen that charge is an entity which can attract or repel entities of same or similar kind when it is surrounded in its electric field. That is what we have seen about charge. But getting more deeper, because studying physics is not only to score well in the examination, but as well as to know why it is. Why is this like this? These are the main objectives of studying physics rather than only the examination motive of it. So we will see the basic properties of electric charge so that we can understand what charge actually is. Because we have just seen the definition of a charge from an examination point of view, but we have not got an idea of, if it is a mango, you know that it is yellow in color and it is so and so shape. But for charge, we have not got such a picture. So we will see in depth about electric charge and understand the exact picture of it. Suppose, we know that there are two types of charges, positive charge and negative charge. So in a system, maybe a closed system or an open system, whatever it is. In a system, let us suppose that there are some charges, random charges. Some are positive, some are negative, and they are arranged in a random fashion. So, if we want to know the total charge of the system, how are we going to find it out? This is the question which can be answered by the first property of the electric charge, that we can add charges together even if they are not of the same sign. Unlike vectors, even if they are not of the same direction, because they don't have direction. Charges are scalar quantities. So we can add the charges even if they are of different signs and give the total summation as the net charge of a system. So if there are three charges, namely plus 3 coulombs, plus 6 coulombs, minus 4 coulombs. So while we add the charges, we are going to get plus 3 plus 6, 9, and subtract 4, minus 4. 9 minus 4 is net charge of the system is 5 coulombs, plus 5 coulombs. So the first property is that you can add the charges to compute the net charge of a system. So when will we need to find the net charge of a system? In cases where we need to find the capacitance. In those cases, you need to know the net charge in the system. So this capacitance is another new term which we have not seen so far, not defined so far. So let me not use that in the discussion. So we will deal it in detail when it comes to that particular topic. So, to compute net charge of a system, we can add the charges irrespective of their signs. This is the first property. Second property is, we know that while rubbing an ebonite rod with silk cloth, there is some displacement of charges that occurs, causing one of the materials to be positive, another materials to be negative. So, do you think that there is a creation of charges in that place? No, it is not like that. The second property of charge is, it can be neither created nor destroyed. Charge is conserved. We can just have transfer of charges from one body to another. If a body has got negative charge, that means it has received some electrons from the body which it was in contact with. It does not mean that negative charge has been created in that body A. It has been received. The electrons have been received from body B to body A. That is what it means. Similarly, now since the electrons from body A are transferred to body B, what happens is body A becomes deficient of electrons, or it has lesser electrons than it had before, so it is now positively charged. So ultimately what happens is just the charges gets transferred and it causes that imbalance to cause charging of bodies. So charges are conserved. This we should have in mind while building any applications related to electric charges. So we will, in this course, we will study more and more about electric charges and their related matters. So we will have to know why these charges are conserved. They are not created. Whereas in some cases, natural cases where a neutron becomes a proton or something like that, there we are going to have a creation of charge. Do you understand? A neutron becomes a proton means then there will be some creation of charge, natural creation of charge. Okay. The third and final property of, basic property of charge is that it is quantized. Okay, fine. In an examination point of view, can just say that it is quantized, that's all. What is this quantization? What do you mean by a quanta? Because we need to know all this quantization. There is a separate branch in physics called as quantum physics. Quanta means some pockets of quantity. Quanta of energy means energy is split into pockets, like let us say quanta of mangoes. That means there are 100 mangoes. Those 100 mangoes are split into 5 kg bags each. Okay, so you are going to have 5 kg bags. That 5 kg bag is treated as 1 unit. So the net mango is going to be a multiple of 5 kg bags. Okay, do you understand? The net mango, you can say that there are 10 5 kg bags. So now anymore we are not going to refer it as 100 mangoes because we have quantized it, yes, a 5 kg packet. Similarly, charge is also quantized. It is quantized as integral multiples of a basic electronic charge. Okay, basic electronic charge, that is the charge of an electron. So charge will be always a multiple, integral multiple of this basic electronic charge. So someone says randomly this amount of charge is present in a body, we can very well verify whether it is possible. If it is not going to be an integral multiple of this basic electronic charge, then that kind of charge cannot exist. See, basically charges are nothing but electrons. No? Electrons are only causing these charges. So if 3 electrons go away, that much of electronic charge is going to be induced on the body which receives it, and positivity is going to be on the body which loses it. So it is always going to be n times value of E. So that n should be an integer, it should not be any other value. So what is this value of E? That is the basic charge which is contained in an electron. Okay, it is infinitesimal. That is infinitesimally very small value. This electronic charge value is very small. It is equivalent to 1.602 into 10 power minus 19 coulombs of charge. 1 coulomb of charge is very high, actually speaking. Whatever we are day to day seeing is in microcoulombs. Then imagine the value of 1 coulomb of charge. Okay, lightnings, they are also in some tens of coulombs of charge. So then imagine 1 coulomb of charge is very great. So we are, then imagine the value of electronic charge, which is 1.602 into 10 power minus 19 coulombs. So with this we have seen 3 basic properties of electric charge. These properties need to be understood in a clear manner in order to proceed further, because these are the basic properties that describe what charge is. Now, these properties only help us to differentiate between a charge and a non-charge. If I have multiple sweets in a box, assorted sweets, and you want to identify what laddu is, you will say laddu is round, it is yellow in color, it has got small particles made up as a ball. All these you say to identify what laddu is. These are all basic properties of laddu. So we identify laddu with these properties. Similarly, to identify what a charge is, okay, see, basically we are studying laws, definition and all. It is not going to be useful unless and until we come to know about what charge is, because around charge only we are going to revolve. Around this charge only we are going to revolve in this entire lesson. So we should know what it is, then only we can go ahead and study about it. Without even knowing English, how can I study novels? It is a difficult task. So to know what a charge is, we had studied these 3 basic properties. Whichever obeys these 3 basic properties, it is a charge. Apart from the definition which we have studied, these 3 properties clearly define what a charge is. Now subsequently, as a part of module 2, let us see why do we need charges. The motivation behind the study of charges. Why is it required? Why should I study? Because many of the students, even when I studied, I used to ask this question, why should I study this? What is required? Why is it required for me in this life? So, charges form the basis of electricity. Okay? When charges move, when electronic movement happens, that is when electricity is generated. Okay? So, all the details about how electricity is caused, why is a person receiving a shock while he touches an electric switch, all these we will study in the electricity and other later lessons of this CBSE syllabus. Now we will just say that when charges move, it causes electricity. That is why we study about charges in order to understand what electricity Okay, so there is a concept called topological sorting. That is, if there are going to be some n numbers, the topological sorting performs the sorting operations. That is, these numbers are sorted. Usually, ascending order sorting, descending order sorting. Topological sorting sorts the numbers according to the order in which they need to be arranged. 2 needs to be visited before 3. Without knowing 2, you cannot know 2 plus 1. So 2 comes before 3. It's arranged in that way. Similarly, without knowing charge, we cannot know what is electricity. That is why we are motivating here to study completely about charge and static charges. Dynamic charges is what we call as electricity. Here we study only static charges. Okay. So in the same module, we will have to see some applications of Coulomb's law and how to compute forces due to the presence of multiple charges. Coulomb's law defines the forces between 2 point charges. What is a point charge? That we have not seen, but we have defined in Coulomb's law. A charge that is infinitesimally small is called a point charge. Infinitesimally means to the level of infinity it is small only. That means it is called as a point charge. So for such charges, we have seen Coulomb's law. If 2 point charges are placed between a distance by r, separated by r, what is the force experienced by each of them? So if there are going to be multiple n charges in an arrangement, okay, we call it as a charge distribution of charges in a system. So that we will study separately. But if there are going to be n charges in a system, how each of the charge will exert a force on each other and what is the net force of attraction or repulsion on a particular charge, that we are going to see subsequently in this module in applications of Coulomb's law and solve a few problems. Okay.